So this is the sheet that you stuck in your books at the end of period 1 on Monday. So it's what it is, it's an algorithm for divisibility of a number, capital N, by any prime number, P, and you will only need to show this for primes that are less than 50. Now, what it does is it gets you to break up the number into two numbers. It gets you to combine them. Sometimes you're going to write your number in the form 10a plus b, and I'm going to explain how you do that. And sometimes, if it's a massive number, to get it down a bit quicker, you're going to write it as 100a plus b, and I'm going to show you examples of both of those. A and b are whole numbers. Then it talks to you about how you could do this. Now, we've already done that. I've already shown you how to do that. And what you've done, you tend to do in your first bit of your question, is you show that if m is divisible by the prime number, then n is divisible by the prime number. We were proving that today. And then we do an iteration where we combine it using n and m and get it down in a much more manageable form, and it's like an iteration. So, and then we're able to say at the end of it. So I'm going to do some examples. So this first question, they're telling you how to break it up. So they're telling you that where capital N is 10a plus b and capital M is a minus 2b, and they give you the suggestion. They're telling you to use n take away 3m. To first of all show that n is divisible by 7 if and only if m is divisible by 7. Now that's really similar to what we were doing today. I'm just going to quickly do that, and then I'm going to show you how they're then going to extend it with this iteration in the second part. So the first thing we're going to do is, we know using their hint that if n minus 3n, we know that n minus 3n is going to be 10a plus b minus 3a minus 2b. So n minus 3n is going to be 10a plus b minus 3a plus 6b. So n minus 3m is 7a plus 7b. And we know we're looking at divisibility by 7, so we instantly are going to write it like that. Now it's an if and only if. So first of all, let's assume if n is divisible by 7, we would then say that n is a multiple of 7. Use a different letter where n, lowercase n, is an integer. So I know that 7n minus 3m is 7a plus b. So I know then that 7n plus 7a plus b will be 3m. So take out a factor of 7. So I know that 3m must be divisible by 7 because you've written it as a multiple of 7. You know that the highest common factor, remember this was the new way we were writing it today, the highest common factor of 3 and 7 is 1. So that means if 3m is divisible by 7, 3 is not divisible by 7, therefore m must be divisible by 7. And now we're going to do it the other way. So we assume if m is divisible by 7, we know m is 7 is a multiple of 7, and we're now going to go back to our n minus 3m is 7a plus b. So n minus 3m, which will be 21, a little m, is 7a plus b. So n is 7a plus b plus 21m. So n is 7a plus b plus, sorry, my capital M's become, so it's lowercase m, 3m. So you can instantly see there that n is divisible by 7. Stop. This is the second part of the question, and this is the new bit. So you can see that it's linked, that should be 9. It's linked to the first part of the question that we've just done. You can see that we wrote the number in the form 10a plus b, and our second we wrote m in the form a minus 2b. Now all they've done, and you've shown that m, capital M and capital N are both divisible by 7. So now you're going to use this iteration, and this is the new bit. So what we do is we take the number that we're wanting to show is divisible by 7. So we want to show that 2,506 is divisible by 7. Now what this iteration does is it lets our first iterate equal our number. So M0 is 2506. It wants you to break this number up in the form of 10 times a number plus another number. So I know that 2506 is going to be 250 times 10 plus 6. So I've written it in the form 10x plus y. So x is 250 and y is 6. What I'm now going to do is write it in this form to get my second iterate. I take the x value and the y value. So my m1 is going to be x, which is 250, take away 2 lots of y, so 2 lots of 6. So what you're doing is you're combining the results that you've used in the first part. So M1 becomes 250 take away 12, which is 238. Now that's still not that easy to show that it's divisible by 7, so you simply do it again. You're now going to write 238 as 10 times a number, which is obviously 23, plus 8. Now that's in the form 10x plus y. So x is 23 and y is 8. And then what you do to get your next iterate is use your x minus 2y. So m2 is going to be x, which is 23, take away 2 lots of y, which is 16. So m2 is 23, take away 16, which is 7. We know that 7 is divisible by 7, so what you've been doing, because you've shown that both n and m in that form are divisible by 7, you've shown that 2,506 is divisible by 7. So therefore 7 goes into 2,506. Stop.